In this video, we are going to discuss various types of signals. Before discussing the various types of signal, first we will define signal. So definition wise, we can say signal is a single valued function of one or more variable which contains some information. There is another definition of signal. Signal is a physical quantity which varies with time, space, or any other variable. So basically you can define signal like that. So now there are various types of signals. So the classification of signals are, first is a continuous time signal and discrete time signal. So continuous time signal, as the graph says, it varies continuously with respect to time. If in the x-axis, if you are keeping time, then according to the time, it is varying continuously. So that type of signal is known as a continuous time signal. Another type of signal is a discrete time signal, which gives some particular value on different point of time. At t is equal to 1, it is giving some value. At t is equal to 2, it will give some another value. T is equal to 3, it will give some another value, and so on. So such type of signal is called a discrete time signal. In my previous videos, we have understood the concept of sampling. So with the help of sampling, any continuous time signal can be converted into its corresponding sample, or you can say any continuous time signal can be converted into its discrete time equivalent. The next type of signal is a real and complex signal. So by a mathematical definition, we will be understanding this real and complex signal, which is e to the power j omega naught t. That is an exponential signal which basically contains two components, cos omega naught t plus j sin omega naught t. Cos omega naught t is a real part and sin omega naught t is the imaginary part. So complex signal consists of real and imaginary, both the parts. So such type of signal is a complex signal, and out of this, any signal, cosine wave, sine wave, these are, you can say, real signals. So it is a combination of real and imaginary signal, which is a complex signal. So this is a cosine wave, this is a sine wave, which is the imaginary part. Then third type of classification of signal is deterministic and random signal. Deterministic means fixed, or the signal whose value can be defined. So this is a square wave. You can say it can be defined from period 0 to any interval t1, and it must be having some amplitude. So such type of signal is a deterministic signal whose amplitude, time period can be defined. Whereas another type of signal is a random signal. Random signal generates randomly. The most common example of random signal is a noise. Noise can be generated at any instance of time, in any instrument or anywhere. So such type of signal is random signal. Fourth type of signal is periodic and aperiodic signal. Aperiodic signal is also known as non-periodic signal. So periodic signal, as the name suggests, it repeats its value after a particular period of time. Whereas aperiodic signal does not repeat its value after a certain interval of time. So mathematically, I can define the periodic signal as x of t plus capital T is equals to x of t. That means after a period of t, the xt will again give the value as xt only. So x of t plus t is equal to x of t. This is a periodic signal. Then next is even and odd signal. Even and odd signal can be defined mathematically as x of t is equals to x of minus t, and odd signal can be defined as x of t is equals to minus of x of minus t. If by graph you can see it is symmetric about the y-axis, it is not symmetric about the y-axis. If you fold this thing, the left hand portion will overlap the right hand portion, whereas in this case, if you fold this, the left hand signal does not overlap the right hand signal. So this is even and odd signal. And finally, energy and power signals. So basically any signal can contain energy or power. If some signal is an energy signal, it will be defined by a capital E, which is 0 is less than E is less than infinity. That means this function or this signal is having finite energy and 0 power. P represents power, E represents energy. So if a signal is having finite energy, its power will be 0. There are some signals whose energies are infinite. So we can say energy is equals to infinite. Then in that case we have to calculate its power, or you can say average power. So in that case power is finite. So energy and power we will discuss in detail when we will solve the questions or numericals related to energy and power. So I hope the various types of signals you must have understood the basic concept. Also you must have now can easily define what is a signal. Okay. So in the next video we will discuss about the various discrete time signals and its functions.